So I thought I'd make a quick video about the experiment I'm going to do. I'm going to test out my program with the video I made yesterday about the phase shift and the frequency. So as you can see here we have the phase. It's currently at almost 92%, degrees. Here we have the frequency at about 100 kilohertz, duty cycle 50%, and the fall time and rise time. The rise is currently 5 nanoseconds, and the fall time, so if you can see, the fall time is about 6 nanoseconds, 6 to 7 nanoseconds. So let's see what happens if we adjust the frequency. So here we are currently switching at 200 kilohertz. The phase shift is 93 degrees. Frequency is 192 kilohertz. Duty cycles exactly 50%. And if we zoom in, we have a rise time of about 5 nanoseconds. And a fall time of again 6 nanoseconds. So now I'm switching at 500 kilohertz. The phase shift is 97 degrees. The frequency is 470 kilohertz. The duty cycle is 50%, and the rise time is 5 nanoseconds. Also, as you can see, there is a little overshoot occurring here at the begins and the ends. But let's take a look at what the fall is again 6 nanoseconds. I am now switching at 1 megahertz. As we can see, the phase is currently 80 degrees. The frequency is just below 900 kilohertz. The duty cycle is again 50%. And if we take a look at the rise time, it's 5 nanoseconds. The fall time is again 6 nanoseconds. I am now switching at 5 megahertz, and as you can see, the phase shift has disappeared because it's now about 10 degrees out of phase. The frequency is at 4 megahertz, so it's 1 megahertz off. Duty cycle is 50%, and if we take a look at the rise time, it's 6 nanoseconds, and the fall should be way higher. It is 7 to 8 nanoseconds, so a significant change at 5 megahertz, or as the scope says, 4 megahertz. I have currently set the frequency to 16 megahertz, but my program doesn't allow greater than 8 megahertz, as you can see, or here. The phase shift is 14 to 18 degrees out of phase. The duty cycle is 51.2% to 52%, and the rise time is 6 to 7 nanoseconds. And the fall time is about 8 to 9 nanoseconds. For switch mode power supplies, I wouldn't go above the 500 kilohertz range, especially because the transformers and such can't handle such speed. But as we can see, at 500 kilohertz, the phase shift is about 100 degrees. frequency is at 470, the duty cycles at exactly 50%, and if you take a look at the rise time of waveform 1, it's about 5 nanoseconds. And if we take a look at the waveform 2, because as we could see it was a little bit different. Okay, the rise time is about 14 to 15 nanoseconds, which is significant than the 5 nanoseconds. So that could cause problems, and the fall time should be different as well. It's about 15 to 16 nanoseconds. Overall, I think this is a pretty good method for now, for simple power supplies and such as that, because low rise times, low fall times, good square waves, only a little bit of overshoot right here, and interference from the other signals when one gets triggered. And let's see if what happens if we change the phase to about maybe 130 degrees. And we see that the phase has shifted. Let's see if we can get the confirmation. Okay, it has gone to exactly half of what I said it would be. Yes, it's 65% of degrees. I'll take a look at that. So now I have changed the phase shift to 20 degrees, but as you can see it has gone to -10, about -10, and it doesn't seem to work very well with non-whole numbers such as 20 or 130. It has to be whole easy radians such as 90, 180. That works fine. I'll just see what happens when you use 45 or something. Okay, so as I expected, a phase shift of about 45 degrees works much better. As we can see, it's 42 to 43% or degrees. So the conclusion is that you need to be in good round radian forms before it starts to work very well. Other than little offsets and mistakes, overshoots and such, I think the Arduino is pretty capable of switching higher frequencies than it's actually intended to do, because usually the frequencies don't go above 110 kilohertz. So yeah, that concludes this experiment, that it is possible, but if you want better waveforms you should just use an actual clock or a IC, driver IC, because if you want to drive MOSFETs and such, you also need high side switching, as you saw in my previous video, and that makes it a little harder. So I hope you like this kind of experiment video, and I'll see you next week.